in this section we will be adding, subtracting, and multiplying radical expressions. For the first problem, we might ask ourselves, how many x's? On the second, we could ask ourselves, how many square roots of 2? Like radical terms are those with the same radical attached, same index, same radicand. Adding like radical terms is just like adding like variable terms. Initially, there are no like radical terms, but it looks like each term can be simplified. What we need to do is simplify each of the terms. As you can see by the midsection of this slide, we square root the perfect square factors. These factors get pulled out and multiplied by the factor that is out in front of each of the terms. In the end, what we find are two sets of like terms. So we finish up the problem by adding the like radical terms. Let's move on to multiplying binomials that contain radicals. And what we're going to do is FOIL as usual. After we FOIL, we will need to simplify each of the terms. So here you can see the process of simplifying the terms, and then we go on to combine the like terms. Focus on the radical factors first, looking for common square roots of numbers. Again, you are looking for the square roots of perfect squares. After simplifying the square root factors, we clean up each term by multiplying the constant factors out in front, and then we also multiply those that would be left under the radical. Your last step is to add like terms. Again, here we multiply binomial factors by FOILing. This time we're looking at same numbers with the opposite signs in those binomials. So on this one, we are multiplying our binomial by what we refer to as its conjugate. And something special is going to happen with this product. We'll see at the end. After FOILing comes the task of simplifying each term. Notice the inner and outer products add to 0. When a binomial is multiplied by its conjugate, an integer always results. In other words, there are no radicals in the final product. When we continue through this chapter, there are times we need to be getting rid of the denominators that are binomials that contain radicals. We will learn we can always multiply by the conjugate, and if we do, that removes the radicals from the denominator. Thank you for listening.